Passing values between a calling statement and a subprocedure or a function involves parameters and arguments. We create parameters in the function definition or the subprocedure definition, and in doing so we're declaring a variable as a particular data type. There's also, though, a word before the variable called by val, and there are two ways of transferring data between the calling statement and the function or the subprocedure. One is by value. The other one we'll look at in the next lesson is by reference. When passing values by value, the value of the argument is passed to the variable of the parameter. So in this example, if you look at the bottom three lines here, this is our calling statement. We've got xyz as an integer, it equals 10, and then xyz cubed is going to equal qubit, that's the name of our function, and we're going to send it xyz, or the value of xyz. That's the value of 10. So 10 is passed from xyz, and 10 goes into the variable x. So we're assigning the argument to the parameter variable. In this case, x is 10. Our function then takes x and cubes it, raises it to the power of 3, so 10 times 10 times 10, which is 1,000, and it returns that value of x back to xyz cubed. So the xyz cubed equals qubit xyz. You can think of the qubit xyz as being replaced by the return value, and we have xyz cubed equals 1,000. We can also pass multiple values from a calling statement to a function or subprocedure. We comma separate them in the parameters. It becomes we'll call a parameter list. So here I have a function called rectangle area. It has two parameters. First one is by val x as double, and the second one, following the comma, is by val y as double. My calling statement at the bottom, I've dimmed my length as double equals 10.5 and my height as double equals 6.0. My area equals the call to the method of rectangle area, and I'm passing it my length, which is 10.5, that goes into x, and my height, which is 6.0, goes into y. The order is significant here in that we'll pass the first argument to the first parameter and the second argument to the second parameter, and so forth. So those are passed in. So now x is 10.5 and y is 6.0, so area as double equals x times y, so 10.5 times 6 is 63, and we're going to return area. So 63, the value of area, goes into my area upon the completion of that function. Let's take a look at refactoring a previous project to use a function. Previously, we created the philatelic discount application in which we applied a discount based on the amount of the purchase. So if it was between $50 and $99.99, we gave a 5% discount, and $100 to $249, we gave a 7.5% discount, and so forth. The only input here is the yellow purchase amount, and then we have a button, calculate amount due, that was named BTN Calc, and its code then figured out the discount amount, the subtotal, the tax, and the total amount due. So there's 5 things it's doing. Oftentimes we have an event handler that's doing multiple things. That's kind of a clue that might be a good place to add a function or subprocedure to break that up a little bit. Let's look at our code. So in our code, we had a value we're getting from txtPurchase.text as our purchase, and then declared some variables. And I want to focus on this code right here. We dimmed % as double equals 0.0, and then a if, else if, else if, else if, else, end if conditional structure that determined the amount of the percentage. I want to refactor that code simply to use a method that we might then repurpose or reuse in another program. So I'm going to rewrite that code as dim % as double equals, and we'll say, we'll call this get %, and we're going to pass it the purchase amount. Now I get a little squiggly under get percent because that no longer exists. Notice I've replaced my if structure, that's gone. So now I need to write my function to return the percentage. And through the magic of video, I'm going to pause the video here and then come back and show you my function. So I have private function get percent by val amount as double. So it's a double variable called amount. We're going to pass the value to it. It's going to return a double value. So get percent is setting purchase. So purchase will go into amount, and then I dimmed percent off as double. And if the amount is greater than or equal to 500, I'm going to set the percent to 12.5%. If it's greater than 250 or equal to 250, it'll be 10%. 7.5% if it's greater than $100, and 5% if it's greater than 50. After that if and if structure executes, my final concluding statement here is that required return, I'm going to return the amount of percent off. That return then will go into percent, and then I continue on with the code here of discount equals purchase times percent, and so forth. Let's run and make sure this works. And so if I do $138.95 and calculate the amount, I'm going to get a discount of 7.5%. That's between $100 and $250. If I change that then to 278, now I'm getting a 10% discount. If I make it just 78, I'm getting a 5% discount. But if I make it 578.95, I'm getting a 12.5% discount. So the program still works as before, but we've broken things up a little bit. One advantage of this is if you're working on this as a team, you could say to a teammate, hey, can you write the function to get the percentage and return that percentage to me? This, in essence, functions and subprocedures become black boxes that can stand alone and can be tested alone, making it easier to debug, and then also be able to reuse them in other projects. And if we had other buttons that we needed to calculate a percentage off, this would help reduce the amount of our code. It doesn't in this case, but it does make it a little more readable and helps modularize our code. If you just jumped into this video, you can see all the videos from the Programming Practicum playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos I create, you can click my picture in the top right to subscribe to the channel.